So in this particular example, we have a group of students in a class and there are 14 in there. Now, 5 of them are boys and 9 of them are girls. And what we're asked to do is pick a 3-member team, debating team. And there's got to be one criteria, and that is there's got to be exactly 1 boy in that 3-member team. So how are we going to represent this on up here as a sample space? Well, one of the best ways to represent it, obviously, will be a probability tree diagram. Why? Because this example has got everything in it. First of all, there's either going to be a girl or a boy. So one of the best ways to represent that is girl or boy. It's going to be a 2-pronged fork like that. And the sample space, well, we're going to be picking 3 members, aren't we? First of all, we're going to pick a member. And what's going to happen to the sample space when we pick one? It's going to shrink or expand? It's going to shrink, that's right. Then we pick another member and the sample space again will shrink. So the numbers will be getting less. We'll start off with 14, take a member out, it'll go to 13, take another member out, and finally it'll go to 12. So there's going to be 3 stages, stage 1, stage 2, stage 3, as we pick each debating member. Remember, boy or girl. So I'm going to put together this particular probability tree diagram, but just remember it's without replacement and the choices are not equally likely because each choice, every time you take one out, is dependent on the other as the sample space shrinks. So I'm going to draw it up for you now, and I'll be right back with the final diagram for you so we can work it out. Okay guys, welcome back. Here's that probability tree diagram representing that 3-member debating team. So what do we got? The main choices are boy or girl, B and G, and we're picking 3 times. How many members? We want 3 members. The first member, the second member, and finally the 3rd member right over there. And the choices are quite enormous because we have the sequence written up there. So how do we pick, as you see the question up there, exactly 1 boy? What are the possibilities? Well, here on a tree diagram, the good news is it's easy to read. So let's have a look at the first possibility. We could have, for 1 boy exactly, we could start off with 1 boy, then get a girl, and a girl, as you can see, it's marked out right over there. Or we could have a girl, a boy, and then another girl, marked out right there. Or finally, we could have a girl, and a boy marked out right over there. So there's 3 possibilities in that sequence. So how do we write that up? Well, I'm going to write it up over there so we can actually work out the specifics. Now remember, each time we pick a person, it's dependent and the sample space reduces because of, without replacement. We're not replacing the committee members. So let's write this up. First of all, we're going to have this one over here, boy, girl, girl. So notice what's happening here. We start off with 5 boys. So probability is a boy, a girl, and a girl. Or we could have the probability of a girl, boy, then girl. So let's have girl, boy, then girl. And finally, we could have the probability of girl, girl, and boy across there. So let's write them out. Girl, girl, and boy. Okay, let's write out each respective individual probability. So we're starting off with boy, girl, boy, girl, boy. Let's write that up. So that's going to be, first of all, for a boy, that's going to yield 5 out of a total sample space of 14. So that's going to be 5 out of 14. And then a girl, so as you can see, boy, then girl here, that's going to go to 9 out of 13. And then we're going across here, another girl, 8 out of 12, as you can see. So that's one group. Let's put in the OR. All right, now we have a girl, a boy, and a girl. So let's find that on the probability tree. We got a girl, a boy and a girl. So we start off there with the girl, 9 out of 14. And then a boy, 5 out of 13. Sample space is shrinking, you'll notice that. And finally, we go across to girl, 8 out of 12 right there. Okay, now finally up here, girl, girl, boy. Here it is again, girl, girl, and boy. Let's write them in. So it starts off 9 out of 14. And we go across here to another girl, which is 8 out of 13. And finally, we have a boy, 5 out of 12. Let's write that in. Close that bracket. So there's our 3 groups of possibilities. Let's put the or in between here. I'm going to put a plus there. Remember, or means plus. Now all we have to do is work all of these out individually. So on your calculator, 5 over 14 times 9 13ths times 8 12ths is going to give us a pretty big number. It's going to be something in the order of 360 over 2184. That's a pretty big number there. So how do we simplify that? Well, if we simplify that on the calculator, it will give us a simpler fraction, and that will be quite simply a 15 out of 91. Now, let's bring the or over here. So the same thing happens here. It's 9, 5 times 8, 14, 13, 12. It's going to be exactly the same. It's in a different order, but it's going to be the same number. So that's going to give us, again, 15 over 91. Let's write that in. Or let's put the or in. And again, on the last one, it's the same numbers in a different sequence. So again, that's going to give us. So all we have to do now is add all them together, and that will give us the final probability for exactly one boy in a 3-member debating team. So let's add them all together. That's going to give us 15 plus 15 plus 15. All together, grand total, the result is